Alright everyone, welcome back to another YouTube video. Today I'm going to be doing some minor improvements on the linear algebra library that I posted yesterday, and hopefully maybe tomorrow or in a couple days I'll be posting one final video regarding this, which will turn the library into a multi-threaded linear algebra library. But yeah, let's just get into it. So here we have our combine function. I wanted to make one function that can do add, subtract, and a multiply function, and even a divide, even though it's the same thing as multiplication really. So I'm just going to copy and paste this error checking here, and now we can do let mut new matrix so we're just going to make a new matrix with the same number of rows and columns, and now here's like the main point of the video that I wanted to show. We're going to be doing this looping in a more Rust-like way. And I'll explain what that means once I finish up with that. It's going to be similar to how I did this apply function. I won't be doing any crazy iterators like this. I don't really think we should do that too often. I would like to keep it as readable as possible. But yeah, so we're going to have for r in, and now we can say new matrix dot data at r. We're going to set each row in our new matrix equal to a new row, and by doing that we can say it is self.data at r. We're going to turn each row in self.data into an iterator, and then we're going to zip it up with the iterator from b.data.r. And then we can call map on two arguments, a and b. A would be from this first one and b would be from this second iterator. And then we can call our function f on a and b. However, we have to dereference them since, as we can see, they are f64 references, but the function takes f64s. And then we can call collect to collect the result from our map into a new vector, and essentially this is its own row, and we set the new matrix equal to that row, and then we can just return new matrix, right? Here I have some tests written up. M1 is going to be a 2-row matrix, and so is M2, and we're just going to add each item up. Or like we're going to add corresponding items in the corresponding places. So we'll do cargo run. So 1 plus 7 is 8, 2 minus 8 is 10, 3 and 9 is 12, and this looks like it works. We can do multiplication, right? That works. We can do division. Yeah. Don't plan on doing that too much. But yeah, so what we did here was we made it a little bit more Rust-like I said. These loops, that's how like any object-oriented programming language would do it. But Rust, being heavily inspired by the ML family of functional programming languages like OCaml, it has this functional way of doing things, right? You turn it into an iterator, zip it up, and you can call a map with an anonymous function. And here we have another one that we pass into the function. I don't know, I think it's pretty cool, and therefore we don't have all this repeated code. Essentially add, subtract, multiply, divide, it would be the same thing repeated. It's like 40 lines for no reason at that point. So we can just delete all of that and just keep our combine function. I couldn't think of another name for it other than combine, but that's it for that function. And now we're just going to go through and make some of our other functions a little bit more Rust-like. Here, we're looping through entries, but instead of doing that, what we can do is entries.iter, and then we can do a for each item ent, and we can push the same exact thing, ent.parse into an F64. Unwrap the result, and that's it. And of course then we can do the same exact thing in our from string function. Except here it's called temp_row. Right? I guess we can just run this again since we're using our from string function. Yep, it works. Perfect. Okay, our copy function can also be made a little bit more Rust-like. Essentially, whenever your iteration or your looping is like a side effect to what you want to do, and you don't actually need this looping idea, you can just do it the more Rust way, where you would do self.data.iter.forEach, and we have each row, and we can just do nData.push row.toVec, and that's that. So yeah, like I said, whenever your iteration is a side effect of what you're trying to do, you can just do it like this. Now what does side effect mean? Really, it's what I've said here. I don't need this index R, really. I'm just trying to access elements at that index. I didn't need the inner for loop for C for column, because I was just accessing elements there. I didn't need any further use. Whereas something here, I do need to use K, because I'm not just accessing an item here. I'm accessing things at different indices. Like here, it's the K column, but here it's the Kth row. Where else? Here, it looks like I don't need it, either of these parameters, row or column, but I actually do. I need to pass in row and column to the cofactor function. If I didn't need to, I could have just done self.data.iter, and I could have had some function here. But yeah, that's pretty much it for this video. I wanted to keep it pretty short, easy upload for me today, and some fun Rust for you guys. Yeah, I hope you guys enjoyed this. If you guys can think of any other more Rust-like ways to do things, please let me know. I'm still learning Rust. I learn something new every day. Same goes for any programming language. I don't think anybody is ever 100% fluent in any language. But yeah, that's it for me. See you guys tomorrow.